Hey guys, Matthew Doyle here, Matthew Doyle Art. I'm supposed to be broadcasting for Carnegie Mellon University here, and I'm going to go ahead and start the broadcast. I'm not sure if the guys at CMU are online yet or not. Hopefully you guys are. I'm going to give you a quick overview of Stingray. We're going to try to do it in 25 minutes, so it's going to be really fast, really high level. I'm not going to be able to cover a lot of detail. But hopefully you guys are here. If you could go in the chat channel and give me kind of a thumbs up on when to start. I don't want to start if you're not here, so I'm just going to kind of hang loose and I don't know, talk to myself or talk to the video. I don't know. But anyway, yeah. So for those of you that are here in the channel, thanks for coming. I see Girl Goes Pow and Morin13. Thanks for watching. Here we go. CMU. Well, it looks like we got you guys joining. Awesome. All right, so fantastic. So I want to thank you guys for coming today, and we're going to try to go through this as quickly as possible, as I was saying. And I'm not going to be able to go into detail on anything because 25 minutes is way too short to cover the entire engine. So let's just go ahead and get started. First of all, let me say, if you want a more in-depth learning experience, there are lots of great tutorial videos out there already. We have a quick start for Stingray on YouTube. Just do a search for YouTube on YouTube, quick start Stingray, and that was done by the Digital Tutor guys. We actually contracted with them to do us like a 20 video long series on using Stingray. And I do tutorial videos as well. I did one on Lua, Intro to Lua, last year that you guys can check out on my YouTube channel, Matthew Doyle Art. And it's about a 2-minute long video on how to use Lua and Stingray. All right, so let's just go with this really quick. So first of all, Stingray is a fully featured game engine. You're going to find all the same tools that you would in pretty much any other game engine in the industry. You've got your 3D viewport, you've got your properties panels, your hierarchical project view. Stingray is project based. You've got a project manager, so we can actually launch the project manager and see a bunch of the projects I have here. Now, Stingray doesn't use a package type system like Unreal. It's more like Unity. So if you're coming from Unity, you're going to be familiar with the workflow here. The asset browser is a hierarchical browser that shows you, where all of your files and assets are, and you can go straight into Windows Explorer and find them that way as well. Here in my 3D viewport, I have this character here that I brought in from Maya LT. I don't know if you guys are using Max or Maya LT, but Stingray comes free with Maya LT. And sending an asset from Maya LT over to Stingray is very easy. You can use the Send to Stingray functionality here, just like you've got Send to Unity and Send to Unreal. So let me actually jump over to the monitor. Okay, so here we have inside of Maya LT, we've got Send to Stingray, Send to Unity, Send to Unreal. And so you could just send your assets that way. You can also use the new game exporter, which lets you break out your assets into individual files for animation takes. And once you send a Stingray, it gives you a live connection. So if you see on the bottom right here, we have this connected to Stingray. I can actually make changes to my asset now while I'm connected and see those changes pretty quick. So if I were to just jump over here to vertex editing mode, make some quick changes to the beak, and we'll just make it longer like that and then hit update. You'll see over inside of Stingray that change propagates right away. So getting assets to and from Stingray using Maya LT and 3ds Max are really, really easy. It has a very tight integration. Plus I can do live camera tracking, which is kind of neat. If I want to see the exact same camera inside of Stingray that I'm getting inside of Maya LT. All right. Let's go ahead and move along here. That kind of covers some of the interop and getting your assets inside of Stingray. All right, so the other thing that's important about Stingray's interop with Maya LT and Max is shader effects. So Stingray uses a real-time shader tool, so GPU-based shaders. And if you look inside of Maya LT here, here's my shader for this character, Francis. I can go ahead and open it up in shader effects. And this is a node-based shader creation tool. This is actually basically visual representation of HLSL or CGFX or GLSL. And this is a physically based shader, so we have metallic and roughness. We have that workflow. And if we actually go over into Stingray and look at the same character's material, all this gets exported as part of the FBX file. So if I open the same shader, let's just make Stingray full screen here. If I open the same shader graph inside of Stingray, give it a second to load. My stuff runs a little slower when I'm streaming because of the CPU usage. All right, so this is the exact same shader graph that was in my LT. And so basically you only had to build your shader once. You don't have to rebuild it. So that's very nice. And we see here the metallic and roughness of the shader. All right, so bear in mind FBX file format to Stingray allows you to send over shader effects, that's your material, as well as level of detail, any LODs, cameras, lights, meshes, animation, as well as human IK data. So if you're doing any human IK stuff, which is full body inverse kinematics, so just briefly back in Maya here, I've got my human IK set up for this character. I can actually do set my control rig here, and I can actually control the character's animation using these effectors. So let's grab an effector here. You can see here it gives me full body inverse biomechanically accurate animations. I can also access that data inside of Stingray. So if we look at, so let's move on to the animation controller. So the animation controller you're going to find is very similar to other animation controllers. So this is our state machine, and like I don't really have time to show you how to put one together, but you can see here I have a basic idle, walk, and attack clips, and these are just basically specifying animations. So in this case I've got an idle animation, and then I have transitions. Oh, excuse me, my dog is freaking. Okay, back with you. So we have our events on walk, on idle, and so forth, and these transition between the states. I can even, if I go into this grouped state here, I can actually play these states, see the preview. I can also put keyframes on the timeline here that do specific things and tie these into my scripting. All right, so that's my state machine, pretty standard. We've got layer-based states. We can have multiple layers here. We've got our events for like on idle, on kick, and so forth, and we can have variables as well. And all of this can be controlled by Lua script or the visual scripting tool Flow. So here's a look at Flow. So inside of Stingray we have a visual scripting tool, and Flow basically is powerful enough that you can create a full game. So you can actually build relatively simple games. You don't want to get too complicated, because when you start having like if-then statements and things like that, and loops and conditionals, it can get really, really complicated in Flow. But rather than go into too much detail here on how to construct gameplay with Flow, what I will say is that pretty much anyone can use Flow. An artist, a designer, you don't have to be a programmer to use Flow. However, you can tie your Flow into Lua script. So bear in mind that there are two types of flow in Stingray. There's level flow, flow that's tied to the level, and unit flow, flow that's tied to an asset, such as my character here. Now, I'll go ahead and load up the character just real quick so you can see some of his flow. But I can't, I don't really have time to detail how it all works. But I'll just summarize some of the flow here. So this is our unit editor window, and it gives you all of the mesh and skeletal hierarchy, as well as physics colliders. We've got our movie here. We use NVIDIA PhysX as well. You can add a PhysX actor here. And here's our unit flow. And inside here, basically, just briefly, I'll tell you what's happening. I've got my attack flow. So my attack flow is just firing off an animation controller event on kick. The animation controller then handles the rest, plays the animation. And here I'm using Wise. So like I said, we have Wise integration for audio, and I'm just firing off a Wise event to trigger a sound effect. Here is all my movement code using Flow. I basically just get my input and I fire off animation events for walking or idle. I also determine what direction my character is currently facing, and then I move him based on that direction and have some speed control and whatnot. Here we have some floor pinning with Human IK. So as I said, Human IK is full body inverse kinematics animation tool, but it also lets you do things like foot pinning and floor pinning and wall pinning, things like you'd see in Assassin's Creed and whatnot. And I have controls for that here. And then I even have some Human IK look at controls. So the character's looking at a sphere as it moves through the level, if it gets close enough to him. And this is all the flow logic I needed to basically say, if the sphere is close enough, within a certain distance, look at it. And if it's not, don't. All right. So if we just run this, you get a quick demo of what I'm talking about with Human IK, and then we'll move on. I'm going to be doing webinars and Twitch feeds on a regular basis, covering a lot of these topics I'm blasting through in more depth. So you guys, be sure to follow my channel, and I'll be broadcasting more details on this stuff. But here we have this quick look at the level here. I'm going to zoom out. So you can see I've got some terrain, and he's actually walking on the terrain, and he's not clipping through it. And then if I walk up to these little cubes, you can see here his feet are pinning properly to the cube as well. They're not clipping through it. Same thing with the ramp. He actually walks up the ramp properly. That's all thanks to Human IK. Now if I turn on his look at controller, now you can see he's going to follow the sphere. He's looking at it, but only as long as it's close to him. Once it's too far away, he goes back to his normal looking direction. All right, so all that's control with flow. Not a bit of code in there whatsoever. Okay, so other than flow, you can use Lua to do scripting. So let me load up another project really quick. And this is a project I used to demonstrate my last Twitch feed, which was about 2 hours long. I did an intro to Lua. Oh, wrong project. I did an intro to Lua, and I went into great depth on how to use Lua with Flow as well as C++ inside of Stingray to control, to do things. Now, this is not a very visual demo, but we'll be able to show you just briefly how this stuff kind of works. So with Lua, you get a very fast portable language. Lua has been around for a while, and it's considered one of the fastest managed language with a virtual machine out there. And it's also very easy to learn. Picking Lua up is, I mean, I picked it up in 2 weeks. So, you know, pretty much anyone can pick it up pretty fast. Let's load up my level here. Now, Lua is a dynamically typed language. So, you know, it's really easy to do variables and things like that, but it can cause headaches if you're not paying attention to what you're doing. And it also has a garbage collector, which, you know, it manages the memory for you. Let's see if I can get intro to Lua to load. There we go. And we'll load up my project here. So here's a quick example look at a Lua file. So if you've used MonoDevelop in Unity, this file is going to look kind of familiar. You have your basic functions like update, render, shutdown. All these functions are called automatically by the Lua virtual machine. And then I have all my custom functions here. And in this case, all I'm really doing with this little bit of my project is I'm printing some stuff to the screen and stuff. But here you can see an example of setting a variable, an actual flow variable. So you can have variables in flow, and I'm setting that variable from Lua. And then you can see an example of getting the data, the variable from flow into Lua. And here I have an example of talking to a DLL that I created. So I created a custom C++ DLL, and using what's called LuaJIT. So LuaJIT is the implementation of Lua in Stingray, which is a faster version of Lua, and it allows you to, well, what LuaJIT does is it compiles the Lua at runtime into C code, so it's even faster than regular Lua compilation. And so using the LuaJIT headers, I can compile a C++ DLL that allows me to call actual Lua functions. So I actually have the DLL here inside of Visual Studio. So here's my example DLL. So if you're doing any kind of really heavy numbers crunching, anything that, you know, requires, you know, C or C++ type speed, you're going to want to do it inside a DLL. And so I have a function here. These are just examples. This is not necessarily what you would do in C++, but this one returns a variable. This one runs a Lua script from a specific location. This one creates a Lua table and fills it with data. This one parses that table. And here's where I'm binding all these C++ functions to Lua functions that I can then call from my Lua code. And so here is what I'm doing. I'm loading this DLL in right here. And then I'm calling all these functions one after the other. Run the Lua script, create the table, you know, return the value, so forth and so on. So again, you're gonna have to check out my intro to Lua video on YouTube if you want to get the actual details on how all that's done. It's pretty straightforward. I'm not a programmer. I'm more of a scripter. I'm a tech artist, but you know, if I can do it, anyone can do it. All right, so yeah, Lua is pretty fast language, easy to learn. Definitely a very good feature inside of Stingray for doing gameplay scripting, and that's where I would do most of my gameplay scripting, because flow is good, but it gets really complex when you got all these if statements, conditionals, and whatnot. So let's jump over to some of the middleware integrations in Stingray, and I think we can be done. So first up, we have lighting. So I'm just going to load another project real quick to show you how lighting is handled in Stingray. Here we go. So Stingray uses Beast. And Beast is a global illumination light map baking tool. So it's not real time, but that's not to say that Stingray couldn't have something like Enlighten as a plugin. But built into Stingray, we have Beast. And Beast lets you bake some very realistic light maps in a very short amount of time. So I'm going to just load up a sample level here real quick. Now these light maps are not currently baked because I was doing some stuff in here earlier, but the idea is we've got these Cornell boxes, and one of them has dynamic lighting with baked indirect. So we have an actual light here that can move around. So we can actually blend between the two, between baked and unbaked lighting. This one's completely baked. This one is baked using emissive lighting. So Beast takes into account, if you have an emissive material, it will take that into account in the bake. And then over here we have one that actually has a transparent material, and so Beast takes that into account as well, so that the light, the shadows and whatnot will look correct. To use Beast, we just go to Window, Lighting, Bake Light Maps. And there's not a lot of options here actually, but you can just set a preset. So you could say quality high or whatever. And then we can turn on live bake and hit bake, and that's it. We can see the baking happen live in the viewport, and it will continue to bake in an iterative manner until it hits the specs that you have put in here. Obviously I don't have time to show you the entire bake, so I'm just going to stop that. So very easy to do light mapping inside of Stingray. Obviously your objects, your meshes have to have UV coordinates on channel 2 for light maps, but that's about it. And in your properties for an object, you would want to specify, you know, its Beast light map settings here, whether it's a baked target, whether it contributes, and so forth. So let's move on to AI really quick. We're getting short on time, but we're almost done. Just a couple more things I'd like to show you. AI inside of Stingray is handled by a tool called Navigation. Navigation is a fully multi-threaded A-star pathfinding tool, and it uses a lot of other performance tricks like time slicing, and it can handle hundreds and hundreds of bots pathing at the same time. It allows your AI to figure out how to get from point A to point B. And it also generates nav meshes. It generates them at edit time, as well as being able to generate dynamic nav meshes at runtime. And it can tie into Flow. All of these middlewares can tie into Flow as well as in Lua, so you can control all this from script. So if I go over to my navigation panel here, also under Window, I can actually generate nav mesh here. So if I change my slope from 45 degrees to 20 degrees, slope max, and regenerate, that changes the nav mesh so that they can't move up those slopes. I'm going to change it back, generate the nav mesh. And the cool thing about navigation, it comes with a debugging tool called NavLab. So I'm going to run this real quick and show you the visual debugger. All right, so here's my level. My AI is pathing. Jump back over here and run our visual debugging tool, Navigation Lab. Give Navigation Lab a second to come up here. There we go. All right, so all I have to do in Navigation Lab is hit connect, since I'm on a local machine here. And I'm going to go to my game camera. And so in this case, I'm actually mimicking everything that the game camera is doing inside of Stingray. So you can see the bots are pathing there. It's tracking them visually. You can see, so if I jump over, oh, I accidentally stopped my level. Let me restart it. Let's play that again. So I can actually get all kinds of profiling data here as well. So let's jump back over into Navigation Lab, reconnect. Sorry about that. All right, so if I turn on my profiling data here, I can actually see things like the bots pathing. So I can turn on the paths and the progress there. I can come over to my profiling tab, get all sorts of data like how long navigation's taking per cycle. That's currently running 0.2 milliseconds. Bear in mind I'm streaming too, so it eats a lot of CPU. All sorts of profiling data on what's happening in your level, and it can all be recorded and played back for later use as well. So it's a very powerful debugging tool. I could spend hours just talking about this tool. It's got so much functionality. So I think overall that pretty much covers most of what I wanted to show you guys. I mean, there's a couple other things. Scaleform is the UI tool. I don't really have time to show you it, but it's a whole new tool that they built. It's not Flash based, and it's tied to Lua as well. That's for creating UI, and it's a very, very intuitive timeline based animation tool. And then of course we have NVIDIA PhysX, Wise, and we do support VR. So if you're doing VR stuff, we have Oculus support. built into Stingray. And I know we're going to be adding a lot of other stuff as well. So I know that I didn't go into a lot of detail. The 25 minutes is a little short to be able to go into detail, but I tried to cover all of the basics of Stingray. Hopefully that worked out for you guys. And if you have any questions now, I'm happy to take those questions. And just, post them in the chat box or whatever. The thing to keep in mind here is it's a pretty artist-friendly engine. A lot of the tools are designed to be artist-friendly, and you can basically make a game without knowing how to code because of Flow. I don't necessarily recommend it because, like I said, it gets pretty heavy when you're building Flow if you start doing all kinds of conditionals and whatnot. But the combination of an easy scripting language like Lua with Flow is going to make it a lot easier to build games if you don't have any programming expertise. That being said, I'm sure you guys have plenty of that. So the question is, how does it relate or compare to Unity or Unreal? So, I mean, that's kind of a loaded question. It's going to share a lot of similarities with the two engines. I mean, Unity shares a lot of similarity with Unreal and vice versa. Crytek shares a lot of similarities. They all have 3D viewports. They all have a asset management tool. They all have a scripting language. In our case, we use Lua. Unity uses C# or Java. Unreal, I'm not sure what Unreal 4 uses. The original Unreal 3 was Unreal Script. Unreal 4 might just be C++ now, no scripting language if I recall. So that's one difference. Unreal has Blueprint, which is their visual scripting tool. Unity does not have a visual scripting tool unless you get a plugin, I think. There might be a third-party plugin. And then as far as quality goes, Stingray's visual quality is up there with Unreal for sure. So we have a physically based shader system. Our rendering, so Stingray is a fully data-driven engine, which means that even the renderer itself can be modified from JSON file config. And the level of visual fidelity, I can load up a quick demo here. The visual fidelity of Stingray is definitely on par with Unreal. We have support for screen space reflections, depth of field, screen space ambient occlusion, all sorts of visual acuity, visual tricks like that that run on the GPU in real time. I would say it's better than Unity as far as graphics go, but that would probably be prefaced by the version of Unity, because obviously Unity 5 is meant to be a lot better looking. I know they've done a major overhaul to their graphics. Let's see here. Just going to pull up this quick level. As far as learning it, I've used pretty much every engine out there professionally, and they all, to me, have a similar learning curve. Some were harder than others. Unreal Script was pretty hard to learn. But generally, just the tools themselves are very easy to pick up. We use the Maya controls in our viewport, so that would be Alt with the mouse left and right and middle. As far as performance goes, I think the performance is pretty comparable. So okay, so you got to run. All right, so I see you're short on time. But anyway, thanks for coming, guys. And sorry we had such a short time. Would have liked to have had more, but hope you guys got something out of it. And you can always contact me. Go to Twitter, Matthew Doyle Art on Twitter, or just email me if you have any more questions or want to see anything else. I'm happy to help out. So take it easy. And I guess that will be my show for the day. So thanks for those of you that made it today. Girl Goes Pow and More N13, as well as the guys from CMU. Thanks for coming in, and we'll see you guys probably next week.